Okay, good evening, students. Let's start today's session. It's 4 o'clock. Can someone confirm that they can hear me? Anyone? Please confirm that you can hear me.
Yes, sir. I can hear you, sir.
Yes, sir. Can hear.
Thank you very much. So let's start today's session. I'm going to switch off my video so you can concentrate on the lecture slides. Okay? Okay, so let's start today's session. We start with module 13, lab session, ICMP. Okay. ICMP messages. ICMP messages is nothing new. You have been using it. A very common ICMP message that you have been using is the ping message. Okay. So ICMP stands for Internet Control Message Protocol. Okay. It gives you feedback about issues related to your connectivity. Your ICMP message protocol, okay, your Internet Control Message Protocol works for both IP version 4 as well as IP version 6. Okay, so its main task is to find out whether you can reach a host. Can you switch off your microphone? Switch off your microphones, please, so that you don't disturb the class. Thank you very much. Okay. So the ICMP messages include host reachability, destination or service unreachable, and time exceeded. Okay. Usually, it helps us to find out whether we have network connectivity. Okay. Now, ICMP echo message can be used to test the reachability of a host on an IP network. For example, from here, we can send a ping from 192.168.10.1. We can send a ping to 192.168.30.1. Okay, to make sure that, hey, is there a network connectivity? Again, I repeat, ICMP is some of the tools we use like ping, like tracert, to find out our network connectivity. Okay, so once we send the echo reply, we ping. Okay, and if we get a reply from the destination, that means, hey, there is a network connectivity. Now, sometimes there are some certain codes related to our ICMP messages. Now, for ICMP version 4, these are the codes related to it, and for ICMP version 6, these are the codes related to it. Now, sometimes when we send a ping message and the time to live, the TTL field in a packet, is decremented to 0, but we still do not get our echo, okay, what happens is an ICMP version 4 time exceeded message will be sent to the source host. Okay, it doesn't exactly mean that there is no echo. Sometimes the echo takes some time to come back. Some of you must have experienced this in the lab. When you send a ping message, the first ping it says destination host unreachable. But the second, third, and fourth, everything is okay, if you remember. This works for both ICMP version 4 and ICMP version 6. Okay. Now, ICMP version 6, the pings for version 6 is a little bit more developed because it has got ND or NDP, Neighbor Discovery Protocol. Okay. Messaging between an IP version 6 router and an IP version 6 device has got two aspects, okay, which is router solicitation message, that is when a device is looking for a router, and a router advertisement message, that is when a router is advertising its existence to its network. Messaging between IP version 6 devices, including duplicate address detection and address resolution, are as follows. One is neighbor solicitation, when a device tells to the network, hey, this is my IP address. Anyone else has the same IP address? Another one is neighbor advertisement. If a duplicate IP address is found, that host will send a message to the host which is sending an NS and say that, hey, I'm having the same IP address as you. Please change. Okay. So you can see that IP version 6 has been planned and developed to make sure that the problems we had with IP version 4 is not repeated. For example, over here, a router is going to send a RA. Okay. It's going to send, remember, it's going to send a router advertisement. It's going to send a router advertisement to its network with its IP address, with its loopback address. Okay. Now, once it sends this IP address to the network, okay, after that, what happens is an IP version 6 enabled router. This is for IP. Yeah, let's talk about IP version 6 enabled router will send out its router advertisement message, okay, in response to your router solicitation message. For example, the PC will say, I just woke up and I want to know I belong to which network, which is the router. So it will send the RS. In response, the router will send a advertisement, router advertisement, RA message. It can also send the RA without any RS. Okay. Once it does that, it will get an IP address. Okay. It will get an IP address from the router. Over here, the router will give it an IP address for this host. At the same time, the host will be asked to use the loopback address of the gateway of this router. So the gateway of this PC is going to be the loopback address of this router. This is in cases of IP version 6. Once the IP address is given to it, remember it has to check that there is no duplicate address. That is known as DAD, duplicate address detection. So for that, okay, in order to do that, what it does is it will make sure that it will send, you see over here, to check uniqueness of an address, the device will send a neighbor solicitation. It will send a neighbor solicitation. And if a duplicate address is found in the network, then that host will send a neighbor advertisement. If there's no neighbor advertisement message coming in, that means there is no duplicate address. Okay. So this tells us about ICMP version 6 basic messaging. Okay. Now, more on ICMP messages that we commonly use are the most common is ping and traceroute. So let's have a look at them. The ping command is an IP version 4 and IP version 6 testing utility that uses ICMP echo request and echo reply messages. This is something that you have used so many times in the lab to ensure that there is a network connectivity. Now, if you are a good network administrator, you may disable the ping message altogether in your network, okay, so that you don't want it to be a security threat. People can abuse it, okay. Ping can also be used to check whether your TCP/IP is working on your system or no. Very simple. All you have to do is you have to ping your loopback address. For IP version 4, the loopback address is 127.0.0.1. For IP version 6, the loopback is : 1. Okay? Even on your computer, you can just test it and make sure that your TCP/IP is active and working. Okay? The ping command can be used to test the ability of a host to communicate on the local network. Okay, so if I want to ping my gateway, what I have to do is I ping my local router, okay, my edge router. So from here, if I ping 10.0.0.254, I should get a reply, okay. Otherwise, there's something wrong with the network. So here would be my default gateway. You have already done multiple times this. You have done this in your lab session. You can also ping a remote host from one network to another network. Remember, a router is used to combine separate networks. So I'm doing an echo request, ICMP echo request, a ping from 10.0.0.1 to perhaps one of the computers over here. If I get an echo reply, that means the ping is successful. Another command that you can use is traceroute. Traceroute or tracert is a utility that is used to test the path between you and the device that you are going to connect. And when I say the path, that means how many routers exist between you and your destination. For example, in this case, you see, traceroute IP address 192.168.40.2. So from my IP address to this IP address, I have got, don't ever count the first one because it always starts with number 1, okay? So from me to this IP address is 1, 2, 3. 3 routers, okay? If a router is not active or it's having security and doesn't want to show its IP address and its presence, then it will be replaced with an asterisk. Now, you can run the same program, the same command on your computer to show from you to whichever website how many routers exist. I'll give you an example. Look here. I'm saying tracert. I want to see from me to google.com, okay, how many routers exist. Now you can see, never count the first one. From me to Google, there are 8 routers. Can you see, my dear students? It's amazing. So from me to my ISP, from ISP to another ISP, and so on, I have to go through 8 hops until I reach www.google.com. Okay, you can try this on your computer as well. Okay, now usually, like I told you, when you start using the traceroute command, it always starts with 1. Now, how does it count the hops? Starts with 1, Let's say you want to see from here to here how many hops you have to go through. So it starts with 1, 2, 3, 4. So the TTL is 4. Okay. When I say hops, remember I'm always talking about router. Okay. One router would be one hop. Okay. But since it starts with 1, okay, the first message sent from a trace route would have a TTL field of 1. Okay. So it always starts with 1, then becomes 2, 3, 4. So the TTL will be 4. Okay. So 4 hops doesn't necessarily means 4 routers, but perhaps 3 routers. Now, that's it. We go to module 14. Okay. These chapters 13, 14, and 15 are very simple. And actually, the previous chapter, number 13, the lab is very simple and it's just some commands that you run. I will upload the lab to Moodle and you can just practice. Lab number 13 is not a lab that you have to submit. Okay. You just do it on your own and get some practice on it. Okay. Now we go to module 14, which is an informative lab session. There is no lab exercise associated with module 14, but transport layer is something that we should know. Transportation of data is its responsibility. And the transport layer, as you know, is one of the layers of the OSI model as well as the TCP/IP model. Okay, transport layer is always between the lower layers as well as the upper application layer. In the TCP/IP model, it's between internet and the application layer. Okay, so we have to know some of the protocols associated with the transport layer. Okay, as I said, it is responsible for the main transport between the internet and the application layer in your TCP/IP model. Okay, so the transport layer has some of the following responsibilities: tracking individual conversation, segmentation of data, and then reassembling the segments, adding headers to your data, identifying, separating, and managing multiple conversation, and using segments and multiplexing. What is multiplexing? Do you remember? Having multiple messages on the same medium. So all of this is the responsibility of transport layer. Now, two of the most important protocols that we have in transport layer are TCP and UDP. Okay, there's a little bit of difference between both of them, but both of them work on transport layer. And this is what this session is all about. What is TCP and what is UDP? Okay, so TCP provides reliability and flow control. So the basic operations of TCP is, hey, have a number on your segments and divide your segments. Why do you need to have a number? Because when they reach the destination, they are not in the same order as they left. There will be haphazard. So that's why you have to have a proper number so that at the destination, they will be ordered and delivered to the destination. There should be an acknowledgement bit. TCP always has acknowledgement bit. Unlike UDP, no acknowledgement. Okay. If a data has not been received at the destination, no acknowledgement. So it will send the data again. Okay, and so on. UDP, on the other hand, is a connectionless protocol. Okay, it is known as a best effort delivery protocol because there is no acknowledgement associated with it. Okay, UDP is used by request and reply applications where the data is minimal and retransmission can be done quickly. Example of some of the applications using UDP is voice over IP telephone, like we use at Curtin, and our domain name system. domain name system where we don't have to type and remember IP addresses. Rather, we type www.google.com. Okay. TCP uses our email, SMTP, IMAP, and POP, and also getting a website on the internet, HTTP or HTTPS. Okay. So in this situation, it makes sense to get acknowledgement. Over here, in live streaming and getting DNS names, you have to be fast. You cannot wait for acknowledgement. Okay? But here, reliability is important. Here, being fast is important. When you stream a movie, which one do you think works? TCP or UDP? Obviously UDP. There's no time to get acknowledgement. Okay, it has to be fast. Now let's look at some TCP concepts. Okay, so in TCP, first you establish a session. Second, ensure reliable delivery. Okay, why? That is why we have got acknowledgement. There should be reliable delivery. And the way the data sent, it has to be assembled in the same way, in the same order, and delivered. And another aspect of TCP is flow control. When the network is very much heavy and it can sense a bottleneck, TCP is aware of all these and will control or reduce its rate of data flow. So it has got that intelligence, which UDP doesn't have. So a TCP header consists of these bits: the source port, the destination port, the sequence number. Remember sequence number so that it can assemble in a proper order. Acknowledgement number. You should have an acknowledgement number to make sure that it gets acknowledged. A header length, a reserved bit, control bits, which consist of certain flags, which we will see, a window size, a checksum size. The checksum size makes sure that the data travels well. And you can see over here, a 16-bit field used for error checking of the segment header and data. And you also have a urgent, a 16-bit field used to indicate the contained data is urgent, and the actual data that is attached to it. Okay. Now, what are the applications that use TCP? Okay, file transfer protocol, they use TCP. When you use HTTP, when do we use HTTP? When we want to surf the internet, request pages from a server. When you get your email, request for your email, okay? These all, they use our TCP. What about UDP? Let's have a quick look. In UDP, data is reconstructed in the order that it is received, okay? Any segments that are lost are not resent. It has to be fast. There is no session establishment, okay? Now, a UDP header, you see, it is not as complicated as a TCP header. It's much more lighter. Source port, destination port, length, checksum. That's it. No acknowledgement over here. Applications that use UDP are DHCP. DHCP is where you get an automatic IP address. When you give a DNS name, instead of using IP address, you can use a DNS name. It's easier to remember www.google.com rather than remembering an IP address. Okay. For email, for file transfer, for voice over IP, for video conferencing, all of these, they use UDP. Now, another aspect of transport layer is port numbers. Now, port numbers are very important aspect because both TCP and UDP use port numbers to manage multiple simultaneous applications. Now, in this case, The source and destination ports are placed within a segment. For example, here you have got a source port and you have got a source IP address. So the source IP address and the source port will make one socket, and the destination port and the destination IP address will make another socket. So you have multiple socket pairs. Okay. The combination of the source IP address and source port number, or the destination IP address and the destination port number, is known as a socket. Now, there are certain port numbers which are related to certain applications, and these are from 0 to 1023. Okay, these are well-known port numbers which are related to certain applications, and we cannot touch it. We also have private IANA port numbers which start from 1024 to 49,159. For example, Cisco has registered port 1812 for its Radius server. Okay, these are registered ports for certain countries and certain enterprises and institutions and companies. We also have private or dynamic ports, which are ephemeral ports. Ephemeral means very temporary, lasting for a few days or even one day. Okay, so which starts from 49,152 to 65,535. Okay, so these are the different kinds of ports that we have. Some of the basic ports, which protocol they employ, and they are used in which application, you can see it over here. Now, you can use the netstat command, okay, to find out which TCP connections, okay, are connected to your host. Okay, and you can use this netstat command to find a major security threat. In fact, on your computer also you can use netstat and see which TCP connections are connected to your PC. Now, how does TCP communication happen? The TCP communication is very famous, and it's a three-way communication process. Okay, first of all, every TCP communication is not working by itself. It has to be assigned a port number as well. For example, a server has got 2 ports. For HTTP, it is working at port 80, and for SMTP, it is working at port 25. So the server can be a HTTP server, can be a SMTP server, or any other server, as long as it has got different port numbers. So an individual server cannot have 2 services assigned to the same port number. There'll be confusion. It has to have different port assigned to it. Okay, these are the famous ports that are related to a protocol. Now, how does TCP connection happen? Okay, 3 steps. Okay, step 1, what happens is the initiating client requests a SYN message. Okay, SYN. If you look at SYN, what does SYN over here? Sorry. What does SYN signify? A synchronized message. So what happens? A SYN message is sent. Okay, sorry. A SYN message is sent from the sender to the destination. And then the destination sends also another synchronized message along with an acknowledgement for this synchronized message. Once that is received, the source will send an established message to acknowledge that, hey, now the link is done. So this is how a TCP connection is established, a 3-way connection system. When you want to terminate a TCP connection, the source will send a FIN, which is finish the connection, to the destination, The destination will send an acknowledgement. It will send another FIN message to the source, and then the source will send an acknowledgement of the destination's FIN, and then it will terminate the session. So a TCP consists of a three-way handshake systems. Okay. So what are the functions of a three-way handshake? It establishes that the destination device is present on the network. It verifies that the destination device has an active service and is ready to accept requests. And it informs the destination device that the source client intends to establish a connection. Okay. So what are the control bits flags that we have for TCP header? We have got an urgent flag, urgent pointer field, an acknowledgement flag, a push function, a reset function, a synchronize, and a fin, okay, which is used for terminating. So chapter 14, my dear students, which we went through, chapter 14 of our lab session, there is no lab exercises associated with it. It's only an information session. But then in your exam, your online exam, perhaps you have to answer some questions related to it. So please don't forget to keep on going through the online content on NetAcad. Now we go to module 15, which is application layer. Application layer, my dear students, which is a combination of application, presentation, and session. Okay. When OSI model came out, application, presentation, and session layer were separate. But like I told you in our lecture session, application layer of the OSI model we have these days is very similar to the TCP/IP model. The application layer is a combination of application, presentation, and session. And some of the most common protocols we have on the top layer, which is our application layer, is HTTP, which is responsible for our internet browsing, FTP for file transfer, TFTP, trivial file transfer, IMAP, and DNS. This is for email, and this is for giving an IP address a more user-friendly name. So earlier, many years ago, when the OSI model came out, the presentation layer and the session layer were not included in application, and they had these functions. For example, the presentation layer was responsible for formatting or presenting data at the source device into a compatible format, compressing data, encrypting data. The session layer was responsible for having dialogues between source and destination application, handling the exchange of information. But these days, all these functions are all encompassed just in the application layer. Okay. Now, here it shows you some of the applications that use this application layer. Okay, your MPG, your MKV file, your MOV file, GIF file, JPJ file, PNG file, and so on. So some of the protocols that we have at the application layer, some of the TCP/IP application protocols that we have is the DNS, the domain name system, which we'll be looking at it more. The DHCP server, okay? Just imagine in an institution like Curtin, where you have got thousands and thousands of devices. If you want to give an IP address statically, individually, the network engineers will go crazy. So what they do, they assign a server or a router to to be a device to give automatic IP address, either IP version 4 or IP version 6. When you do your CCNA tool, okay, you will know how to make your router an automatic DHCP server so that it will have a pool of address, and that pool of address, whichever device connects to it, it will get a IP address automatically. Okay, so that's your DHCP. And of course, HTTP. How do you surf the net? By using hypertext transfer protocol or hypertext transfer protocol securely. Okay, HTTPS. Okay, so these are some of the protocols and the ports that they work on. So one of the most important applications that we have in the application layer are the peer-to-peer application as well. One of that which is different from peer-to-peer is the client-server application, where as a client, when you surf the net, as a client, we request services, or if you are accessing a database, your client software accesses a database server and requests data from it, and so on. Okay. Unlike a client server, a peer-to-peer network, they're connected in such a way that both the computers can be a server and a client. If I'm getting a data from you, then you are a server, I'm a client. If you are getting a data from me, then I'm a server and you are a client, and so on. Okay. There are many applications that use peer-to-peer chat systems and BitTorrent. Okay. Streaming is a big thing these days, so people download less. But if you download stuff from the internet, legally or illegally, you are most probably using a peer-to-peer application. Okay. We also have web and email protocols at the application layer. Some of these will be going through it. Okay. A most common protocol that you have is the HTTP, Hypertext Transfer Protocol and Hypertext Markup Language. The language, your HTML, is used to translate the web pages that are coming from the server and translated on your personal PC. So how does the system work? Very simple. Step one, you open a browser and you type a URL. URL is a uniform resource locator. First, you mention which protocol you use, http://. Then you type the server name, www.curtin.edu.my. Then you type the specific file name, index./index.html, which will take you to the main page. Okay. Once you make the request from your computer to the server, guess what happens? In step two, the browser checks the name of the server to connect to, and then it will find the IP address related to www.curtin.edu.my, because that is a DNS name. It will find the actual IP address. Once it finds that, then it will give a HTTP request with a GET request, and it will try to get your index.html file. In step three, the server sends your index.html file in the form of HTML code, and your browser can translate your HTML code into a proper web page. This is what you see. Okay, so that is what your HTTP protocol does, and gets the page in the form of HTML on your computer. Now, both HTTP and HTTPS do the same thing, except HTTPS is a secure version of it. Okay, it's a secure protocol, and both have got common message types like GET. It's a client request for getting data. Post, when you want to fill up a form and you want the data from the form to go inside your server, then you use post. And put is when you want to upload information to the server. Okay, so get, post, put, these are certain message types. If you know HTML, then sometimes you have to use get, post, and put aspects in your HTML or JavaScript. Now, email is another application at the application layer which we use a lot, and there are some protocols associated with it. The first protocol is SMTP protocol. The next protocol is POP, Post Office Protocol, or IMAP. Both POP and IMAP are similar. There's a subtle difference between them which makes IMAP better. Okay, usually a sender will send the email, okay, to a certain person. Now, from the sender, it goes to when you give the email address, it goes to that server denoting the email address. So when it's sent from the from the source, from the sender to the server, it uses a SMTP protocol. Sometimes it may not send, if, for example, if you're sending, it may send, if you're sending from Curtin, it goes to your Curtin server. But if you're sending from your home, it goes to your ISP, and then from your ISP to your Curtin server, something like that. Okay. Now, when you're downloading the email, then you use POP3 protocol to download it. Okay. Sorry. POP3 is used to download from the server to the recipient. SMTP is used to upload from the sender to the server. Now, there is a better version of POP3 which is known as IMAP. See, what happens is POP3, when you download the email from your server to your computer, it moves all the email to you. That means it deletes all the email from here and puts it inside the recipient. What does IMAP do? It just makes a copy and puts it on your computer. And there will always be a link between you. If there is a network connection, there will always be a link. If there is no network connection, it will synchronize later. If you delete an email here, later on it will go and delete the email over here. So every time you can access it on the website, as well as you can access it on your computer standalone by using an application like Outlook and so on. Okay, so IMAP is a better version of your POP. Now, IP addressing services, most common amongst them are your domain naming service, which is another service in your application layer. Remember, I told you it's much more easier to remember www.curtin.edu.my rather than an IP address. Okay, so that is why we have got a domain name service which translates that IP address into a fully qualified domain name, something like http://www.cisco.com. FQ, the ends are easier to remember. Okay. Now, the DNS server stores different types of resources. Okay. Different types of resource records that are used to resolve names. Now, these record types can be an end device, which is an IP version 4 address. It can be quad A, which is IP version 6 address. It can be NS, which is an authoritative name server. or it can be a MX, which is a mail exchange record. Okay. The DNS server, usually the DNS always uses a hierarchical system to create a database to provide name resolution. Let's say you're looking for a page. If the name to IP address is not found within that network, it will go to a higher level, to the root level even, to find out what is the DNS name of that, what is the IP address related to that DNS name. Examples of top level domains are .com, .org, .au, I mean country, IP addresses, and so on. Now, you can try this command, my dear students, the ns lookup command. It is a computer operating system command that allows a user to manually query the DNS server configured on the device. You can try it on your computer, my dear students. For example, when I try on my computer, it says, hey, my DNS server is cdns01v6.tm.net.my. This is my DNS server. Okay, a TM computer, which gives me, this is the IP address, IP version 6 address, which gives me my DNS name. Okay, this is my DNS server. Now, besides the DNS, we also have a DHCP protocol. Okay, the DHCP server can be configured on a computer or on a router. Okay, what does a DHCP do? As the name says, Dynamic Host Configuration Protocol, it automatically gives IP address to the network. When you boot up your computer will link to the DHCP server. In this case, it may be a router or a computer, whichever you have in your network. Usually it's a router because it's much more easier. So it links to your router or your local DHCP server, and it gets an automatic IP address. Okay, like I said, when you do your CCNA 2 router and switch configuration, one of the lab exercises is, how do I make my router a DHCP server? The commands you have to remember: once you select your router to be a DHCP server, you give the command of a pool of IP address. From this IP address to this IP address, I want you to give to any client which connects. Okay. Now that lab exercise we don't do in CCNA 1, that is in CCNA 2. Okay, so we will do it, perhaps you will do it when you study your distributed networks. We also have file sharing services. Okay, a common file sharing services is FTP for establishing a connection, and you can establish a connection by using port 21, and by using port 20 you can transfer the file. Okay, once the file can be transferred by using port 20, you can also download and also upload the file. Now, instead of using FTP, there is a better version known as server message block. It is also a client-server request response file sharing protocol, except it is a much better option where you can start, authenticate, and terminate sessions, control file and printer access, allow an application to send or receive messages to or from another device. Very similar to FTP, except clients establish a long-term connection to servers. After the connection is established, the user of the client can access the resources on the server as if it's on his own computer. Okay, so server message block is much better than your FTP. Okay, so that brings us to the end of our application layer. The lab associated with this is also a very simple lab, and this one also I'll upload it, and you don't need to submit it, you just do it on your own, so you get a better idea of how to do how the protocols work in your application layer. This brings us to the end of the session, my dear students. I will upload this video to Moodle. I've been recording, so I'll upload it to Moodle. So you can have a look at it whenever you want to understand some concepts better. Okay. So this brings us to the end of the session. We have got about 15 participants. Very good. Okay. Remember the lab exercise for last week. Please submit it to me. That is very important. Okay. Please submit it to me. And the most important lab exercises, my dear students, you have already done. We will meet again next week at the same time, Wednesday, 4 p.m. I will send you the Webex invitation again. Anyone has any question? Okay, if you don't have any question, we stop the session. Okay, and I will see you all next week. Thank you very much for your attention. Please stay safe and take care of yourself. Okay, I will upload more files on Moodle. Don't forget to do the lab of last week. Okay, and send it to me. And please finish those exams of NetAcad as well, the open book exams. Remember, 75% is the passing mark. Thank you very much. Have a good evening. Take care of yourself. Bye.